A stomp rocket is in flight for 5 seconds. How high did it go? So the only thing we're given is T total. We actually have to use several equations to solve this problem. We have two of them, the first kinematics equation and the second kinematics equation. When we get further on in this course, we'll find a third equation that solves this problem a lot quicker and easier, but we don't have that yet. So what are we going to do? The first thing, the total time is 5 seconds. So that's the time it goes up and it comes down. The apex, the time it gets to the top, is half of that time. It spends as much time going up as it goes going down. So we will say our apex time is 2.5 seconds. We have our first kinematics equation here. We want to find V initial, and you'll see why in a second. So V initial is going to be V final minus AT. We just subtract AT from both sides. And then what is A? A is the acceleration due to gravity, which is G. So it is now VF minus GT. What's our velocity at the top here? It's 0. Okay, because when going up, we had positive velocity, going down negative, so we cross the 0 point of velocity right there. So we put in 0 minus, now, A is equal to a negative G. So we put in negative 10 there, and look how the negatives will cancel, times the time, 2.5 seconds, which we found here. We have an initial velocity of 25 meters per second. Now we switch over to the second kinematics equation, where delta y is equal to the initial velocity times time minus 5t squared. Now where did this come from? Okay, that term was actually plus 1/2 at squared. Well, what's a equal to? A is equal to minus g. So that equals minus 1/2 gt squared. And what's g equal to? 10 meters per second squared. So we take half of that and we get the 5. See how we're taking shorthand on this? The more you do these problems, the quicker you can go through them by making quick little substitutions. So we now have delta y is 25 meters per second times 2.5 seconds. That's the time it takes to get to the apex. Minus 5 times 2.5 seconds squared. Be sure you do the square. And you find that the total height of the rocket is 31 meters.